This is Unit 8, Polynomial Functions, and today we're going to learn Lesson 1, Function Notation from a Graph. A lot of this unit is going to be review. We're going to talk about composite functions, how to plug into functions, how to find all of the roots of functions. To do that, we'll use synthetic division. We're going to talk about operations on functions, inverse functions. So we're going to be kind of intermingling some of the old information with the new information so that we can go further. In this example, they're asking us to use the graph of f of x to find the following points. And they give us f of 2 equals, and they want us to find the y value for f of 2. And remember, back earlier in the semester, we learned that f of x is the exact same thing as y. So anytime you have f of x equal to something, we know that you're finding the y value. So if x is the number inside the parentheses, basically what they're asking us to find here is they want us to find the y value when x equals 2, and when x equals 3, and when x equals 4, 5, and 6. So what we're going to do is we're going to go to the x value of 2 on my graph, and then I'm going to find where that x value, or what the y value for that graph is when x equals 2. And it looks like right here, when x equals 2, the y value is at -8. So f of 2 is going to be equal to -8 in this graph. For f of 3, I'm going to go to the 3 for the x, and then I'm going to go down until I figure out where it crosses, and that looks like it's about right there. So f of 3 is -4. F of 4, well, if I go to f of 4, look at this. It's an open circle right here. An open circle is not included. I'm looking for a solid dot at f of 4, or when x equals 4, and that happens when the y value is here at 3. So f of 4 is 3. A common mistake for a problem like that is students just look at this bottom part, they see that open circle, and they say that f of 4 is -1. But in this case, that would be wrong. F of 4 is the solid dot of 3 right here. F of 5, when the x value is at 5, I'm right here at 0, so the y value is 0. And f of 6 is at -1. So that's how we read a graph when we're dealing with f of x equals your y value. So we learned earlier in the year that if I have f of 2 equals -8, that's the same thing as the ordered pair 2, -8. F of 3 equals -4 is the same thing as the ordered pair 3, -4. And you could find the ordered pairs for all of these different function values. They want you to find x this time, and now they're giving you that f of x equals a number. So now, if we know that f of x is equal to y, then haven't they in this term, or in this problem, given us the y value? And they're asking us to figure out what x value would be in the parentheses to give us this y value. So let's see, when is y -9? Okay, here's my y value of -9. So for what x values does that happen with? Well, that happens when x is 2 and when x is 8. So in this one, I have two different numbers that I could plug in for x. Y is -9 when x equals 2 and when x equals 8. So I had two solutions for that problem. Here they're asking when is f of x, or when is y equal to 3? Well, y equals 3. Here is y equals 3 right across here, and that happens at one spot right here when x is 4. So when x is 4, we get a y value of 3. When is y equal to -1? Well, here is our -1 value for y. It's an open circle here, so I cannot say that that's at x equals 4 because it's an open circle. But I can say that it happens at x equals 6. In the next example, this graph is a little bit different. This is a piecewise function, meaning we have two different parts of the graph. They're separated, but that's okay. We can still answer all of these questions. F of 1, they want the y value when x equals 1. Well, at x equals 1, that's an open circle, so I don't include it. The closed circle is at the y value -6. So f of 1 is -6. F of 5, if I go down, that would be at -2. So the y value at when the x value is 5 is negative 2. F of negative 2, the y value when x is negative 2, looks like it happens right here at 4, so the y value is 4. And here they want us to go in the opposite direction. If the y value equals negative 4, what is the x value? Well, when the y value is negative 4, we are right here. And look at how many times that happens. That y value is at negative 4 in 3 different spots. That happens at 0, 3, x equals 6. So it's possible to have more than one answer for an equation like this. When does y equal negative 5? Y equals negative 5. Well, right here, that's an open circle, so we don't include that one. But it happens twice. Y is negative 5 here and right here. Now, there's a little bit of a problem here. For this one, I could say x equals 2. That's one of my answers. But for this one, that's at a fraction point. We don't know where that is. So if something like that happens, we're just going to put that happens between x equals 6 and x equals 7. Another way you could say that is you could say that happens when x is between 6 and 7. So x is between 6 and 7 would be how you could do that one. Now, in Delta Math, they're not going to give you ones that have a fraction like that, but I wanted to make sure you understood how to approach that if something like that were to happen. But again, in Delta Math, you don't have to worry about that. F of x equals negative 1. When is y equal to negative 1? Well, y equals negative 1 right here, and that happens when x is negative 1. In this one, I want you, this is review of stuff we've done before. It says to use set notation to answer the following. And remember, in set notation, we will use parentheses if it does not include the endpoint, and we will use brackets if it does include the endpoint. And it says to find the domain and range. Well, remember, domain is a list of the x values. So if I'm looking for the domain of this piecewise function, well, as we move from to the left and to the right, if we think about that, this x value, it goes forever in a left upward position. So doesn't that mean that all x values to the left of negative 8 are going to be included? So our domain is going to start at negative infinity, and it's going to go until, now there's a break in the graph right here. There's an open circle at negative 2, but then there's a solid circle at negative 2 as well, so negative 2 would be included. And then it's a solid dot everywhere else on this graph, and this continues forever in the upward right direction. So that means all x values are going to be included as we go further to the right. So our domain goes from negative infinity to infinity. We would use parentheses anytime we use infinities in set notation. For the range is a list of the y values. Now, if we think about that, we're going to start from the bottom and move our way up. Where is the first y value going to be located? Well, right here is the lowest point on that graph. So the y values aren't included until we get to negative 6. Would it be included at negative 6? Well, yes, it would, because that is a solid point at negative 5, negative 6. So our range begins with negative 6. It does include negative 6, so I'm going to put a bracket there. And then if we look at this, we have a solid portion or a solid line for every other y value. If you look at this, it goes forever up toward the upward position, toward the right, and this one goes forever toward the left up. So the graph here, the y value of the graph, is going to continue upward until you get to infinity. Again, when we use infinity, we always use parentheses. So the range here goes from and includes negative 6 to infinity. Here it says determine where the function is increasing and decreasing. A function is increasing when, as we move from the left to the right, the function is going in an upward direction. The function is decreasing when, as we move from the left to the right, the function is going in a downward direction. So if you look at this, as we move from left to right, so we're moving from left to right in this direction, looking at whether our function is increasing or decreasing. Well, as I move from left to right for this function, look, it's going down. It's continuing in a downward direction until I get right here. After I pass the x value of -5, it continues in an upward direction until I get to the x value of -2, where it starts to go in a negative direction again until I get to x equals 3, and it goes an upward direction again. Now, when we're talking about intervals where a function is increasing and decreasing, we are talking about the x values for those intervals. The only time we talk about y values in intervals is when we're talking about the range. Otherwise, all interval notation will be done, or set notation will be done, based off of the x values. So this function, now it started out decreasing. So we can say that the function decreases from negative infinity. So it decreases from negative infinity until we get to -5. Now, at -5, it's not increasing or decreasing. That's where it's changing direction. So it does not include -5. That's why we put a parenthesis here. It then increases from -5, and again, it doesn't include -5 because it's not increasing or decreasing there. That's where it changes direction. And it's increasing from -5 until we get to the x value of -2. Since at -2, that's an open circle, it's not including -2. It's decreasing again from -2 until we get to 3. Since at -2, this is where the direction changes, we're not going to include the -2. And again, at 3, since that's where the direction is changing, we're not going to include the 3. It does continue to increase then from 3 to infinity. And again, anytime we use infinity, we use parentheses. And then in the last examples, we're talking about plugging into algebraic functions. So for this one, f of x equals x squared plus 3x minus 28. If they ask us to find f of 0, what they've done here is they've replaced this x with 0. So they want us to replace all of these x's with 0. So we would have 0 squared plus 3 times 0 minus 28. And if we solve that, we have 0 plus 0 minus 28. F of 0 is equal to -28. In this example, they want us to find x when f of x equals -18. Well, our function that they gave us was f of x equals x squared plus 3x minus 28. And if f of x equals -18, they're telling us to replace f of x with -18. So now that I've replaced it, I can then add the 18 over, and I'll factor that to solve it. Factors of 10 that subtract to give me 3, well, that would be 5 and 2. So I have x, I have a 5 and a 2. I'm going to have a plus 5 and a minus 2 because this tells me the signs are different, and the big number gets the plus. And then if I just set each of those equal to 0, I get x equals -5 and x equals 2. So my answers here, I had two answers where the y value is equal to -18, at -5, and at -2. I want you to do this one. Pause the video, see if you can get this one on your own, and then I'll put the work up here and you can see your answers and check and make sure you got them right. So here are your answers. When x equals 2, f of x is 9. So f of 2 equals 9. F of -1 is -6. And then the x values when your y is equal to 0 here are -5/2 and 1.